In this lecture, you'll learn about RAG, Retrieval-Augmented Generation for LLMs. We spoke about LLMs in the last lecture. They are large language models and they're susceptible to hallucination where they generate incorrect output data. For example, a router configuration with errors. And this is because the data that this particular LLM was trained on did not include information about routing configurations. So if you then put in a query to this LLM asking it to create one, LLMs are not good at saying they don't know. They will give you an answer. And if they don't actually know the answer, it's going to have incorrect information in it. So this is a known problem with LLMs. General LLM models are very good at generating natural text. They've been trained on a huge amount of text, so they're able to speak in a natural kind of language, but they can fall short when technical knowledge of a topic or up-to-date information is required. Also, generally, when the LLM is created, it's got that data set, it is trained on that data set, which is going to give it general information and train it to speak naturally. But once that's done, it's not common for it to be updated again after that. So it's only up to date to when it was actually trained. You may be able to include data such as a running configuration as part of an input prompt to an LLM, so you can give it some context that way, but there's going to be a maximum length of the prompt that you can enter, and it's really just not a very scalable solution. So how can we reduce hallucination? Well, you could build a new LLM model, your own one, from scratch, and build it with a relevant data set with the data that it's going to be actually used for. So you could, for example, include network configurations in there. However, creating an LLM can often run into the millions of dollars, so this is obviously out of the reach of organizations. It's very expensive due to the expertise, time, and compute resources required to actually do that. So that's really just not feasible. Next option is fine-tuning. This is where you've got a pre-existing LLM and you load additional relevant data to it and then use techniques such as backpropagation to tune it. So there are public LLMs available. You could download one of those and then you could add your own data to it. But when you add your own data to it, you are going to have to tune it to make sure that the output is correct. Doing that is not as expensive as building a new model from scratch, but it's still very costly and time consuming because you're going to need experts who know how to tune the LLM. It also carries the risk of the model forgetting previously learned information. This is a known issue that can occur if you add data to an existing LLM that can actually cause it to forget information that it learned already. And both options are impractical for keeping the data up to date. So again, you've got the same issue there that once an LLM is trained, you're typically not going to be adding new data to it again, because if you do that, then you would need to retrain it again. You would need to do the backpropagation again to make sure that there's no errors. So those are really not feasible options typically, and that's where RAG comes in, Retrieval-Augmented Generation. That does enhance the accuracy and currentness of an existing LLM. So that's the solution for those problems. And the way it works is it uses an external database. So you've still got the LLM, you've got an external database as well, which is where you add your relevant and up-to-date information. And when queries come in, it uses both the LLM to generate the language in the response and also the external database so that you've got relevant contextual information and it can be constantly kept up to date as well. RAG can be used by nearly any LLM. It's all running on standards. It's relatively easy to implement with public tools and knowledge bases available. So your organization could be using a public LLM. Those are available that you can download. And there's also public knowledge bases. There might be one which has got the relevant information for your particular scenario already there. Internal knowledge bases can also be used which remain private. So you can take a public LLM and then you can create your own private knowledge base to use as an external database. You can use that all internally, and your internal knowledge base is not going to be leaked out to the public. So how RAG works? Well, first off, we have to create that external database. You need your knowledge base first. So that can be things like running configuration examples. It can be articles with relevant information, etc., things like that. Then with that typically text-based knowledge base, you're going to do pre-processing first. So the knowledge base is split into tokens and chunks. So for example, if you have got a sentence that is going to need to be loaded, is going to need to be searchable, you split that into tokens, which could be the words or even smaller in that sentence, and then they're expanded into chunks, which are a bit longer, but still smaller than the overall sentence. So the knowledge base is split into tokens and chunks and converted to a machine-readable numeric vector format. Then an embedding model creates a vector database optimized for search and retrieval. So you've got your knowledge base, which is all your text articles. That gets split into tokens and chunks with pre-processing and converted to the machine-readable format. Then it is the embedding model which takes that information and creates the vector database from it. The vector database is optimized for searching for that relevant information which is in your knowledge base. In the background, the embedding model continuously updates the vector database as the knowledge base is updated. So you can add new information to your knowledge base, and the embedding model is automatically going to update the vector database with that new information, so it's automatically kept up to date. Then, once your vector database has been built and you've got your LLM, then your users can start sending queries in. They can start using the LLM. When users enter a query, the embedding model converts it into that numeric format again, which is compared to the vector database for any similar relevant information. Matches are then retrieved and sent to the LLM along with the query. The LLM combines the retrieved entries from the knowledge base with its own response to create the final output for the user. So you've got the LLM is going to be creating the natural language in the response, and then it's able to be technically accurate and up to date because it's also using information from the database. So looking at a diagram of that, so first off, we need to create the vector database. So we have got our knowledge base here, the information that we want to add. It goes through pre-processing. So you're going to use some software to do that. That is going to break it down into tokens and chunks. And then the embedding model creates the vector database from that. Once that is done, we've got a user and they're interacting with an AI application such as a chatbot. So for example, they say, please show me an OSPF configuration example for this particular scenario. I've got these routers with these interfaces and networks. They send that to the chatbot. It then goes to the embedding model. It's converted to the numerical format, and then the embedding model checks the vector database for similar contextual information to that. When it finds some, that then gets retrieved, it gets fetched from the knowledge base, and that relevant information gets sent to the LLM along with the user query. The LLM is then able to create the response using that relevant information as well, and that is what is sent down to the user. So how can we use RAG in network operations? Some examples for configuration generation. In your knowledge base, you could include different configuration examples. Now, when a user sends in a query, asking to the LLM to generate a configuration for it, it can use that relevant information. You can also use it to help with troubleshooting. Your knowledge base can contain relevant IT articles, also previous incident reports from inside your organization and their solutions. So it's highly relevant, And whenever there's new incident reports being created, you add that to the knowledge base and the solution as well. Then if you've got a network engineer and they use the chat bot where they say, I've got this issue, please suggest a solution, the LLM is able to do that. You can also use it for up-to-date documentation generation. So you can load information about your network devices into the knowledge base, and then you can ask your AI application, please create a network diagram for me. It's able to do it because it's able to look up that information. Also, because the RAG database can be constantly updated, this is really useful for keeping your documentation updated as well. And the last example, predictive maintenance. So in your knowledge base, you could have previous maintenance schedules that have been used, any anomalies, so any hardware that failed earlier than usual. Also, what environmental data you've got, what the heat has been, and any vibration statistics you've got for your devices. And then your AI could do predictive maintenance where it says this particular hardware might fail early. We recommend you check it, maybe swap out a part. Thanks for watching. If you want to get hands-on practice with Cisco networks for free, then you can download my 400-page CCNA Lab Guide, which you can see above my head right now. Also, check out the video about my CCNA course. It's the highest rated course online. Thanks.